According to the 2005 National Electrical Code, Section 410.4d addresses fixtures in bathrooms. Open lamp fixtures located within 3 feet of a shower or bathtub must be listed for damp locations. This requirement impacts installations by mandating the use of fixtures specifically designed to withstand moisture and humidity. In small bathrooms, compliance may involve replacing existing fixtures with damp-rated alternatives or installing shielded fixtures that prevent direct water contact. As for recommendations under 410.4d, prioritize damp-rated fixtures listed for bathroom use. Also consider shielded fixtures to further minimize direct water exposure. The 2005 NEC also covers equipotential grids in Section 680.26c. If an existing paved walking surface becomes part of a pool deck and is within 3 feet of the pool, the equipotential grid must extend under that surface to that point. In such instances, cutting into the existing surface might be necessary to install the grid. A suitable alternative involves installing a new perimeter grid around the pool, preserving the existing surface. The recommendations for 680.26e are firstly coordinate with the homeowner and pool builder to determine the optimal method for extending the grid under the existing walking surface. Secondly, if cutting into the surface is necessary, execute it carefully to prevent damage. Thirdly, consider installing a new perimeter grid to avoid disturbing the existing surface. The reasoning behind these code requirements stems from safety considerations. Electrical safety in wet environments is paramount. Damp-rated fixtures prevent electrical hazards in bathrooms where moisture is prevalent. Equipotential bonding minimizes voltage differences in and around swimming pools, reducing the risk of electric shock. When selecting damp-rated fixtures, look for listings from recognized testing laboratories, such as Underwriters Laboratories, Intertek, or Canadian Standards Association. These listings ensure that the fixtures have been tested and meet the required safety standards for damp locations. Consider the fixture's ingress protection, or IP rating. This rating indicates the level of protection against solid objects and water. A higher IP rating offers greater protection. When extending equipotential grids, ensure that all metallic components are properly bonded, including pool equipment, handrails, and other conductive elements. Use appropriate bonding connectors and conductors that are suitable for burial. The size of the bonding conductor is determined by the size of the power conductor supplying the pool equipment, as specified in NEC Table 250.122. Grounding and bonding are critical for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or ground fault circuit interrupter (GFCI) and energizing the circuit. Bonding connects metallic components together to equalize their potential, preventing voltage differences that could cause electric shock. Ground fault circuit interrupters are required for receptacles located within a certain distance of a swimming pool or bathtub. A GFCI detects small imbalances in current, indicating a leakage to ground, and quickly trips the circuit, preventing electric shock. Regular inspections and maintenance are essential to ensure the continued effectiveness of electrical safety measures. Check fixtures for signs of damage or corrosion. Test GFCIs periodically to verify their proper operation. The NEC is updated every 3 years to incorporate new technologies, address emerging safety concerns, and reflect changes in industry practices. Staying up to date with the latest edition of the NEC is crucial for electrical contractors, inspectors, and homeowners. Continuing education courses and professional certifications can help electricians and other professionals stay informed about the latest code requirements and best practices. Proper planning and coordination are essential for successful electrical installations. Before starting any electrical work, obtain the necessary permits and inspections. Consult with a qualified electrical engineer or inspector to ensure that the installation complies with all applicable codes and regulations. Safety should always be the top priority when working with electricity. Energize circuits before working on them. Use appropriate personal protective equipment (PPE), such as gloves, eye protection, and insulated tools. Follow lockout/tagout procedures to prevent accidental energization of circuits. Electrical hazards can be deadly. By following safe work practices and adhering to the NEC, you can minimize the risk of electrical accidents. Remember that electrical codes are minimum safety standards. In some cases, it may be necessary to exceed these standards to provide an extra margin of safety. For example, you may choose to use a high-rated GFCI or install additional bonding conductors. The goal is to create an electrical system that is as safe and reliable as possible. Always consult with a qualified electrical professional if you have any questions or concerns about electrical safety. They can provide expert advice and guidance to help you make informed decisions. The 2005 NEC is a comprehensive set of rules and regulations designed to ensure the safety of electrical installations. By understanding and following these requirements, you can help prevent electrical accidents and protect lives and property. Electrical safety is a shared responsibility. Everyone has a role to play in ensuring that electrical systems are installed and maintained properly. Homeowners should be aware of basic electrical safety practices and should report any potential hazards to a qualified electrician. Electrical contractors and inspectors should be knowledgeable about the NEC and should enforce it diligently. By working together, we can create a safer electrical environment for everyone. The NEC provides specific requirements for wiring methods, overcurrent protection, grounding and bonding, and equipment installation. These requirements are based on years of experience and research and are designed to minimize the risk of electrical hazards. The NEC also includes provisions for special occupancies, such as healthcare facilities, hazardous locations, and agricultural buildings. These occupancies have unique electrical safety requirements that must be addressed. In addition to the NEC, there may be local codes and regulations that apply to electrical installations. These local requirements may be more stringent than the NEC and must be followed. It is important to check with your local building department to determine the applicable codes and regulations. Electrical installations should be inspected by a qualified electrical inspector to ensure that they comply with the NEC and local codes. The inspector will examine the wiring, grounding, bonding, and equipment installation to verify that they meet the required standards. If any deficiencies are found, they must be corrected before the installation is approved. The electrical work should only be performed by qualified and licensed electricians. Electricians have the training and experience necessary to perform electrical work safely and correctly. They are also familiar with the NEC and local codes. Hiring a qualified electrician is the best way to ensure that your electrical work is done properly. Do-it-yourself electrical work can be dangerous and is often prohibited by law. Electrical work requires specialized knowledge and skills and should not be attempted by untrained individuals. If you are not a qualified electrician, you should always hire a professional to perform electrical work. In addition to the NEC, there are other standards and guidelines that provide information on electrical safety. These include standards from the Institute of Electrical and Electronics Engineers, the National Fire Protection Association (NFPA), and Underwriters Laboratories (UL). These standards cover a wide range of topics, including electrical safety in the workplace, electrical equipment testing, and electrical system design. Staying informed about these standards can help you improve your understanding of electrical safety. The NEC is not a static document. It is constantly evolving to reflect new technologies, address emerging safety concerns, and incorporate changes in industry practices. The NEC is updated every 3 years, and each new edition includes revisions and additions to the code. Staying up to date with the latest edition of the NEC is essential for electrical professionals. Continuing education courses and professional certifications can help electricians and other professionals stay informed about the latest code requirements and best practices. The NEC is a complex and comprehensive document. It is not intended to be read from cover to cover. Instead, it should be used as a reference guide to answer specific questions about electrical installations. The NEC is organized into chapters, articles, and sections. Each section addresses a specific topic related to electrical safety. The NEC includes tables and figures that provide additional information and guidance. These tables and figures can be helpful in understanding the code requirements. The NEC also includes definitions of terms that are used in the code. These definitions are important for understanding the meaning of the code requirements. The NEC is a valuable resource for electrical professionals. By understanding and using the NEC properly, you can help ensure the safety of electrical installations. Electrical safety is a critical aspect of building design and construction. By following the NEC and other applicable standards, you can create buildings that are safe and reliable. Electrical systems should be designed and installed to minimize the risk of electrical hazards. This includes providing adequate overcurrent protection, grounding and bonding, and equipment installation. Electrical systems should also be maintained properly to ensure their continued safety and reliability. Regular inspections and testing can help identify potential problems before they become serious hazards. Electrical safety is a shared responsibility. Everyone has a role to play in ensuring that electrical systems are installed and maintained properly. By working together, we can create a safer electrical environment for everyone.